Hi guys, make sure before beginning this set of notes, solving inequalities using multiplication and division, that you have already, completed the first page of notes, solving inequalities with addition and subtraction. This is the basic steps of isolating your inequality. You make sure that you finish these notes first before you are on this new page of notes. With that being said, we can get started. In order to graph an inequality, you again have to use the inverse or opposite operations to isolate the variable just as you would to solve an equation. You want the variable by itself, like x is greater than 4, or y is less than or equal to 10, or w is greater than or equal to 13. This is what you're aiming for. That way you can actually graph the inequality. The inverse operation of multiplication is division. The inverse operation of division is multiplication. Remember, they're at the same level of power. They are the opposites of each other. When graphing an inequality where the number is a solution, you're going to use a closed circle. So again, that's with these symbols. The little line, little extra underneath, means that the circle is going to be filled in. It's going to be closed. When graphing an inequality where the number is not a solution, you're going to use an open circle. That's for your regular less than or greater than. That means the circle on the number line is just going to stay open. Remember, I'm going to use a new color. The multiplication property of inequality and the division property of inequality. They both say the same thing. Whatever you do to one side, you got to do the same to the other in order for it to be balanced. Now, granted, this is not an equation where it has to be balanced, but in order to correctly isolate the variable, whatever you multiply to one side, you got to do to the other side. Whatever you divide to one side, you got to do to the other side. And you guys are familiar with that already. I want to point out one more thing. It has to be by the same positive number. Because when we're getting in inequalities, we're talking about number lines going up and down in positive and negative integers. This rule applies when you multiply each side by the same positive number, it remains true. And when you divide by the same positive number, it remains true. When you move on to 7th grade, you're going to do more operations with negative numbers, like adding, subtracting, multiplying, or dividing. For now, we're just worried about the positive ones. Number 8, to check your inequality solution set, you're just going to choose any number that was shaded in and see if it's true. Then you're just going to evaluate it, and by that, ask yourself, is this reasonable? So let's get started on the first one. I'm going to focus right here. I'm going to zoom in. I have 2g is less than or equal to 10. Eventually, I want g isolated by itself. I did not change the symbol. I just dragged it on down. So there's a number next to 2 I need to get rid of. 2 smack next to a g means to multiply. That's the same as 2 times g. So I need to do the opposite of multiplication. Well, the opposite of multiplication is division. So I'm going to divide each side by a number. I need g by itself. The 2 is the one I need to get rid of. So whatever I divide on one side, I'm going to do the same to the other side. This is the same as 10 divided by 2. 10 divided by 2 is 5. So there is my isolated variable. And I can go through my steps. I'm actually going to pull out my notes from the earlier lesson. I need to place my circle on the isolated variable. So in this case, my variable is isolated. That means the circle is going to go on positive 5. Now the next step, oh, be careful, I need to double check and see if this is going to be an open or closed circle. The line is underneath. It's less than or equal to. That means this number is included. I'm going to color this in. And then the very last step, I need to highlight the solution set, the numbers that make this true. So I'm going to read it again. G is less than or equal to 5. The alligator's eating the 5. So that means G is any number smaller than 5. 4 smaller than 5. Oop. 0 is definitely smaller than 5. Negative 5 is definitely smaller than 5. And frankly, the number line they gave me, I don't have any other option to go up the number line. So that works perfectly to shade in my solution set as all the numbers less than 5. Or equal to 5. It can also be 5. That would make this still true. So now I'm going to check. I'm going to zoom out. And over here, I'm going to pick a number that I highlighted and plug it into my original inequality from before. Not just my isolated one. I want to plug it in and see if it actually works with my first problem they gave me. I'm going to pick, let's just pick 2. I'm going to circle 2. That means instead of 2 times G, I'm going to zoom in, and I'm going to say 2 times 2. Well, let's see. 2 times 2 is 4. Is 4 less than or equal to 10? Yes. This is true. That would totally work. All right. If you need to pause to get all this information down, please do so. I'm going to go ahead and move on to the next example. I have H divided by 3. So the opposite of division is, multiplication. That means I need to multiply. Whatever I multiply on one side, I got to do the same to the other side. I could have also just done the dot, but for now, we'll just use the X to represent. I want H isolated. I want H by itself. So the number I need to get rid of is this 3 here. When I multiply on one side, I do the same to the other side. That cancels out. 1 times 3 is 3. There is my isolated variable. I'm going to go through my steps. First step, need the circle to be in the right spot. It's isolated, so that means my circle H is greater than 3. Circle goes right on positive 3. Now I'm going to check to see if I use an open or closed circle. Oh, well, it says right here, it's going to be open if it's just less than or greater than. So in this case, it doesn't have the equal sign line underneath, so that circle is going to stay open. And now I'm going to plug in numbers to see if this will work. Well, is 2 bigger than 3? Well, no, 2 is not bigger than 3. That wouldn't work. Is 4 bigger than 3? Oh, yeah, that'll work. Is 5 bigger than 3? Yep, that'll work. All right, so now I plugged in some numbers to see what makes this true, and now it's giving me a clue that all my numbers need to be shaded in this direction. Be careful not to accidentally color in the open circle. You need it empty. So there's my graph. And now I'm going to check using my original inequality. And even though I don't see it, I could pick any number up the number line. In this case, I'm going to go to the next number I would have seen there, which is 6. I'm going to see if 6 would work. So instead of H divided by 3, I'm going to do 6 divided by 3. 6 divided by 3 is 2. Is 2 bigger than 1? Yes. That is true. All right. So now this is what happens when asked to solve multiplication or division inequalities when you want to isolate that variable. Make sure if you need to pause or rewind to do so. When you're ready, you can move on to the next page. Just like on the notes, the previous notes, you need to isolate the variable for all of these, graph them on the number line. You're going to have to put the numbers you want because all the numbers can wind up in different spots. These ones on our notes were pretty close together, right around positive 2, positive 3. But now you got numbers up in the 72 region, 12s again, 66. So you have to put in the numbers and then make sure you check. So over here, when you check, you need to start with 8 times G is greater than or equal to 72. So when you find your solution set, plug in and guess a number for G like this, not just your isolated variable. Don't just check this. You need to check the original inequality. All right, you are ready to get started.